What is up, mathematicians? And today we are going to be practicing how to decompose whole number fractions greater than 1 using number equivalents. So we're going to be looking a little bit more into our knowledge on equivalent fractions. Let's get into it with our I will statements for today.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these 3 things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen to me first. I will create number bonds with fractional units. Read that one with me. I will create number bonds with fractional units. The second one. I will create number lines with fractions. Read that one with me. I will create number lines with fractions. And our last one. I will identify equivalent fractions. Read that one with me. I will identify equivalent fractions. Nice job, mathematicians. Let's start with our warm-up for today.
For one of your reviews today, you are going to be playing Around the World. How this game works is you will each start by sitting on top of your desk. While you are sitting by your desk, one student will stand by the person next to them. Each of the students will be shown a math problem at the same time. It might be a multiplication problem, addition, subtraction, or division problem. Your job is to say the answer as quickly as possible. Whoever says the correct answer moves on to the next seat over. If you answer incorrectly, you move and sit in your seat and watch and cheer your friends on. The goal of the game is to get all the way around the room by answering all of the facts correctly. I will post the rules on the screen for you to pause and talk about. If you have any questions, ask them now. Come back and play the video to see which math problems you will be using for this round of Around the World.
All right, mathematicians, for this activity, I want you to draw the same number bond that I have on my whiteboard on your whiteboard. So pause the video and do that now. Now that you have this number bond drawn onto your whiteboards, if we were to look at this number bond, we would have to determine if it's true. So is this statement true that if I have 2 1/2, if I split it up, would it be 4 1/4? Well, to figure that out, we could look at how much each of these equals as we combine them. So 1/2 and 1/2 together, I know equals 1 whole. So inside of our circle, we have 2 1/2 or we have 1 whole. If we looked at our 4 outside circles and we were to combine them or add them all together, we would have 1/4 plus 1/4 plus 1/4 plus 1/4. And if we added all those together, we would have the bottom stays the same. 1 plus 1 plus 1 plus 1 is what, everybody? Call it out. 4. If you got that, nice job. Give yourself a high five. So 4/4, I also know that equals 1 whole. So all of our outside circles, they equal 1 whole as well when we added them all up. So in looking at this picture, this is a true statement because 4/4 comes from cutting halves into 2 equal pieces. Or when we just added them and got our 4/4 here, we would get 2 halves here, and both of those are equal to 1 whole. But what happens if I change this picture just a little bit? Watch this. If I added 2 more halves into the middle, do that onto your whiteboards now. We didn't change our outside circles. So we still have 4/4 or 1 whole as all of our outside circles added together. But do we have 1 whole in the middle still, or did we change it a little bit? Well, let's look at it. Before, we had 1/2 and 1/2 by itself, and we knew that was 2 halves or 1 whole. That's the same as this side. So this side, 1/2 and 1/2 would equal 2 halves or 1 whole and as well. If we have 2 wholes and we add them together, or we add all of these fourths together, we're going to get a total of 2 wholes. And looking at these, our outside circles do not equal the inside circle on our number line. They're not equivalent fractions. There are many more parts in that first model, so they aren't equal. Our extra copies that we added of 1/2 created an entire extra whole that we needed to deal with. And because of that, that means that we're comparing 1 whole on the outside to 2 wholes on the inside, not making these equivalent fractions or equivalent images either. You're going to continue to look at some more number bonds, and you're going to manipulate and change them kind of like we did here in order to see if they are equivalent fractions or not. Remember, equivalent fractions means that they equal the same. So in this case, our fractions inside our circle and outside are not equivalent because they represent 2 different amounts. But in our first example, just watch me, you don't have to do this. When we had our 2 halves and we added those together, they did represent 1 whole, and they equaled out to the outside circles on our number bond. Now clear whiteboards, mathematicians, take a quick stretch and prepare as you work together